Hello, dear viewers, you souls who love mystery and peaceful slumber. Welcome back to our channel, where mysterious stories are told to guide you into deep, enchanting dreams. Is there anything more wonderful than immersing yourself in a mystical tale, letting the darkness and secrets lead you into sleep, where your imagination can soar freely? In this episode, we will dive into the hidden world of termites, tiny architects who build secret fortresses underground, where life thrives in darkness and the vibrancy of a superorganism. Get ready to explore the wondrous and surprising. We hope you'll enjoy tonight's story, letting it gently lull you into a deep dream-filled sleep. Let's get started. On the East African savanna, termite mounds seem unremarkable, unless you've seen inside them. You've never witnessed their secret life, untouched by sunlight, or the scale of the fortresses they construct. These eyeless insects crowd together. Yet, the more we learn about them, the more people come to admire them, especially when you understand their role in global ecological relationships. Studying termites can be daunting. They aren't an easy species to work with. They have their own rules. But two veteran scientists are about to share a profound discovery, a glimpse into the secret sanctuary of termites, a mystery that has resisted investigation for years. Retirement should have been a well-deserved reward for two biologists, Joanna Darlington and Reinhard Littold. But when you're as consumed by termites as they are, you can't rest when so much remains unknown. They disagree on details, but both know these ancient insects are pivotal in ecosystems worldwide. They are key agents in decomposing dead plant matter. The sun-baked soil and organisms like bacteria or fungi can't survive near the surface. Termites help these arid lands thrive, but often there's no sign of them. They're hard to study because they avoid exposure. So much of my work is practical. Studying termites is like archaeology, excavating buried cities, drawing conclusions from evidence in abandoned places. When you open a termite mound, the termites vanish deep underground, as if they were never there. But one group of termites can't escape because they can't move. The challenge is how to observe them without destroying their nest. The sanctuary lies within the chamber of the termite queen. The queen, a colossal hyperproductive mother, gives birth to every individual in the colony, which can number up to 1 million. Together, they form a unified superorganism. Immediately, worker termites rush to seal the entrance Joanna just opened. Sudden changes in temperature, humidity, and light send them into panic. But it's an orderly panic. The workers have water ready to create instant cement, even in such arid conditions. Soldier termites, with their powerful jaws, guard the closing gap, ready to fend off intruders. In mere seconds, the researchers glimpse the heart of a termite superorganism, or rather, its womb, where the entire colony is born. In many countries, termites are feared, despised, and hunted. They can be just a few inches away, and you'd never know unless you call an expert. They'll crawl under floors and into unimaginable corners. In homes, too, cut open a beam, and you'll be stunned by these creatures. Your house isn't a cozy home to them. It's an unlimited buffet. They'll take anything they can eat. What are termites? Some call them white ants. Completely wrong. Ants have existed as long as termites and are also social insects. But unlike termites, many ant species are carnivorous, with other insects often on their menu. Ants evolved from wasps, while termites are descendants of cockroaches, and they are entirely herbivorous. In fact, termites eat everything from lichen to rotting wood. That's one of the secrets of their success. They're not just pests. Let's journey through the digestive system of a drywood termite using computed tomography imaging. Its gut is designed to process cellulose and lignin, the tough materials encasing plant cells. Termites bite off tiny wood fragments. First, they're softened and shredded, all within less than 0.04 inches. Inside, the wood fibers are pushed through the digestive system until they reach a special gut segment, like a stomach filled with single-celled organisms called ROI, which break down cellulose. ROI make up a third of a termite's body weight. Without them, termites would starve. They extract vast energy from cellulose and pass it to the termite, leaving only tiny specks of waste you wouldn't even notice. A termite colony can live quietly in a house for years without anyone realizing they're under attack, with only subtle signs and faint sounds. In Kenya, termites are part of the landscape. Locals respect the massive termite mounds. Farmers protect them, even when they're in the middle of fields. Occasionally, a tractor may crush a termite tunnel. These tunnels extend far beyond the visible nest. Here's a young adult termite, almost ready to leave the nest to build a new one. Termites try to stay underground, but to find mates and suitable places for new colonies, they must surface, often at night. This is the most dangerous moment of their lives. Farmers value the moist, fertile soil around termite mounds. Anything that helps crops grow better here is welcomed. 5,280 miles away, on the island of Bono, the climate seems made for termites. The rainforest is always humid, warm, and shaded. This may be the environment where termites first emerged. The termite species here thrive, needing neither to escape heat nor dig deep for water. They nest in hollow tree trunks, unlike their drywood termite cousins in America. These termites don't eat the wood they live in, so they must venture out to forage every 10 days. Scout termites identify harvest sites and chart ideal routes through tangled terrain. These routes are marked with pheromones secreted from glands in the scout termites' abdomens for others to follow. Their dark chitin shells offer some resistance to sunlight. And now, the harvesting team gets to work. A patch of lichen clings to a tree trunk 328 feet from the nest. In human terms, that's about 9.3 miles. These young worker termites, with their sharp little jaws, don't eat outside. They scrape, cut, and gather as much as possible in a frenzy. The entire army operates on a schedule. In under 30 minutes, the tree is stripped clean. Then the transport team takes over. A division of labor that's existed for 100 million years. This termite waits until fully loaded, then sets off. The harvesting and transport teams seem to know when it's time to return, unless distracted. The wrinkled white powder at the mouth of a pitcher plant is termite eggs, enough to wipe out an army or pull them all off a lichen-covered tree. But the mouth and interior of the pitcher are slippery. A single pitcher plant with a few traps can capture thousands of termites and digest them slowly. The termite colony brings back about 1.1 pounds of plant material, enough to sustain 1 million termites for about 10 days. A perfect system with no overseer. But venturing outdoors always carries risks. The greatest danger is dehydration. That means sun-scorched areas must be crossed as quickly as possible. Gaps in the forest canopy are a problem. Logging is a disaster. Termites have softer shells than ants. If exposed to the sun too long, They'll cook themselves. When the sun rises, they huddle in the shade, hiding in darkness or racing back to the nest. Termites prefer to venture out in the morning or afternoon, when the sun is just rising or about to set. Their thin skin can't withstand cold dew or rain. When the rain clouds clear, the journey continues. This trip goes smoothly, with no predators attacking. Losses from carnivorous plants are negligible. Back at the nest, the colony stays underground for about 10 days, processing their harvest and tending to the next generation. Back in America, the war on termites continues. You can poison, fumigate, or use electric waves to kill them. But there's one problem. No matter how thoroughly a building is treated, a new generation of termites may be preparing to reinvade from the backyard next door. In this war, termites outnumber humans. In East Africa, too, but here, termites aren't seen as pests. A massive termite mound with single ventilation chimney tells a story. Termites dominate the ecosystem here. In human scale, this mound would be about 5,577 feet tall. They must build so high for the ventilation system to work efficiently. Simply put, the taller the trees, the larger the mounds. Astonishing, isn't it? To observe a termite colony building a new ventilation system, Joanna Darlington and Reinhard Little stay up all night. This mound is still under construction. They need a gentle light source to avoid panicking the termites. An infrared camera helps. Reinhard Little records a colony's activity. Tens, thousands of workers carry soil, clay, and water from deep underground. In the short term, they're gathering building materials. But in the long term, the minerals they bring up enrich the surface soil. They mix clay with water, carried in their bodies using their mandibles. To find water, they can dig tunnels up to 197 feet or more down to groundwater. The work is relentless but orderly and doesn't take much time. The task never stops. The termite mound lives, eats and breathes like a giant organism. Comparing it to a living creature is entirely fitting. The mound's breathing rate is close to that of a mammal. It's also extremely humid, reflecting the climate inside the nest. When a rare rain cools the air, you can see water vapor rising from the ventilation chimney. By dawn, this chimney has grown about 1.6 feet taller, still unfinished. Afterward, every gap will be sealed. Termites regulate airflow to keep the queen's chamber at 86 degrees Fahrenheit and nearly 100% humidity. This mound is alive and breathing, but not all mounds breathe the same way. The main difference lies in their ventilation systems. Different termite species have chosen different ventilation methods for their mounds. This mound is steaming heavily, that one too, and so is another. This one's just starting to function. The key here is the difference between the upper and lower ventilation holes. As wind strengthens higher up, the upper holes draw air in from the lower ones, creating airflow through the mound. To survive in such a hot, dry climate, termites need an air conditioning system. But these ventilation chimneys don't just cool the nest. They also release gases like carbon dioxide and methane. Single chimney mounds are especially valuable to Joanna and Rahas. They use them to measure gas emissions, estimating the number of termites in the mound. But dismantling a large chimney requires great care, as it's built to last. By multiplying the numbers from one mound by the number of mounds across the savanna, you can estimate the greenhouse gases, especially methane, that African termites release into the atmosphere. If calculated accurately, we could determine their contribution to global warming. But science isn't precise enough yet. We can't reliably estimate the total biomass of termites. We have data on how much methane each termite species emits, but we don't know their exact population size or mass. So, yes, termites contribute to greenhouse gases, but we don't know exactly how much. It's easier with livestock. Cattle also emit methane, produced in their guts during metabolism. But with cows, we can count heads and calculate their methane output. With termites, we can't. We know there are many termites, but we don't know their total biomass. We need to learn more about them. Cutting deep into a mound's base reveals the tunnels of an underground city. Stray termites from the nursery are the last to flee for cover. Once again, entomologists become archaeologists as their living subjects vanish before their eyes. Joanna Darlington and Reinhard Little continue investigating termite nests in Kenya. Another nest goes unnoticed. It takes a child's keen ears to hear them. Finding someone as meticulous as Rose is rare these days, but all she does here is erase traces. Drywood termites have an old saying, "My home is my meal." No need to expose themselves to enemies. Working in place is so efficient it makes them relentless. In fact, termites cause more damage to homes worldwide than storms, fires, and floods combined, over $20 billion annually. Here, the next generation prepares to thrive. The main cast, the reproductive termites, are sprouting wings. In just a few days, thousands will fly into the light, mate, disperse, and establish new colonies. In the tropics, the total biomass of termites is immense, but to the average traveler, they're nearly invisible. Amid the chaotic brown carpet of the forest floor, these termites have found ways to navigate rough surfaces to reach food sources. When the height difference between leaves and branches is too great, they build bridges and tunnels using sand and soil from the forest floor, a different kind of termite concrete. They use it to construct direct routes to food, saving time and effort. This is a superhighway, guiding rush hour through the most complex terrain. Pheromone trails orchestrate smooth traffic, like road signs and traffic lights. The tunnels are even designed with 2 lanes, one for outbound, one for return. Soldier termites line the route, facing outward, sniffing for danger. This is a larger body cast, their heads transformed into chemical weapons. Their antennae sweep the air. The forest is always full of threats. Closer to the nest, the tunnels are built more spaciously. Nothing halts their progress. Worker termites tear apart dry leaves to bring back to the nest. The debris they leave behind decomposes, helping young trees grow on the forest floor. Tearing dry leaves is hard work, taking about 2 hours to process a single leaf. And this termite species only eats leaves. We're only beginning to understand termites' role in global ecosystems, but they seem to positively impact nearly every plant and animal. So, instead of focusing on exterminating termites, some researchers argue we should protect them worldwide. Over 150 million years of evolution, termites have learned to process every type of plant, living or dead, into their primary food. This adaptability is their greatest strength. With a perfect social system, termites can dominate their habitats. But in the Borneo rainforest, a predator lurks, coiled in the dry leaves. It looks like a snake. When stretched out, you might mistake it for a pangolin. And indeed, It's not a reptile, but a mammal. This is the pangolin, with long claws to break open termite nests and a sticky tongue to lick them clean. Today, the termites are lucky. The pangolin's dinner is an ant nest instead. But termites don't just face pangolins. These soldiers detect a different enemy, one they can't see but can sense. A team of weaver ants is stalking the termite column. The ant scouts have chosen a perfect ambush spot. The ant patrol slowly approaches the termite highway. The worker termites seem too busy to notice the danger. Some soldier termites catch a strange scent but can't abandon their posts. The ants take their time, searching for gaps in the termites' defenses. Finally, they opt for a direct assault. But the termites aren't entirely helpless. The smaller soldier termites fire with precision, try to wash off the acid sprayed on them. Other soldiers counterattack and engage. A few ants retreat with termites in their mouths, but the termites hold their ground thanks to chemical weapons. On the savanna, another ant army is on the move. This time, it's not just a minor skirmish. The formation advances quickly and focused, led by a scout. They fan out from the nest in 3 parallel rows, each about 6.6 feet long. These ants are like bloodhounds, specialized in hunting termites. There's no escape. The savanna termites have no secret weapons and are overwhelmed by numbers, size, and powerful jaws. The ants drag termite carcasses back to their nest along the same route they attacked. Biologist Joanna Darlington has witnessed many such battles. She's always amazed at how 2 insects can be so similar yet so different. Termites and ants are not the same species. Termites are the most successful terrestrial insects. I believe they were the first social insects. But the fossil record is incomplete. Despite similarities, ants and termites are not related. They are an example of convergent evolution, where different species solve the same problem in similar ways. She continues calculating the biomass of termites on the savanna. She maps all the termite mounds in the area, identifying 2 types living side by side. One builds mounds. The other lives entirely underground, usually venturing out only at night. They spread across the savanna, collecting plants, dragging more than their body weight. The ground is dotted with small holes sealed during the day, leading to a network of tunnels around the nest. This network extends up to 115 feet from the nest. A single termite colony can have up to 3.7 miles of tunnels. Termites clear dead grass and wood debris, reducing wildfire risks in the dry season. Back at the nest, they eat decayed plant matter. This termite species can break down cellulose, like their American counterparts. Some house-dwelling termites chew and moisten cellulose into coarse waste, then use it to cultivate fungi. That's what this mound-dwelling species does. The Maasai women have never seen inside a termite nest, but Reinhard Ludolf installed a window to observe the fungal garden. The termites tend to the fungal comb, the nest fungus-growing section. Worker termites build it layer by layer, taking weeks to complete the structure. The fungi produce white spores called conidia. Workers swallow these spores and excrete them with waste, enriching the fungal garden. This is a primary food source for the entire colony, and the species' survival depends on maintaining precise temperature and humidity in the nest. For the Maasai women, it's their first glimpse of the insects that keep their land fertile. Meanwhile, in California and the southern United States, a good termite is a dead termite. desperate homeowners call exterminators. Entire houses are fumigated with toxic gas from top to bottom. Climate control in buildings and cities has helped termites spread far beyond their original habitats across America, Australia, and parts of Europe and Asia. Termite extermination is big business, but even that doesn't guarantee success. In Kenya, Joanna Darlington and Reinhard Little are nearing their goal, reaching the queen's chamber, the most sacred part of the nest. They finally found a suitable mound to work with. Removing the queen's chamber is simple enough, but opening it without damaging the nest is delicate. The chamber must be carefully inverted. Joanna Darlington and Reinhard Little have waited for this moment for years, but they must be cautious. If the royal guard termites panic, they may attack the queen. And here's the decisive moment. Not one, but 3 termite queens. The king, only about 0.4 inches long, mates with the queen for life, up to 35 years. Trey, another researcher, brought an entire lab to Savannah. He hopes the queen's king workers and larvae will behave naturally in an artificial chamber. Tubes connecting the chambers to the natural nest are coated with pheromones to encourage workers to continue caring for the queen. The other 2 queens and the king are returned to the nest, hoping they'll find their way. Over the years, researchers have tested similar setups, gradually refining the technique. But restoring the queen's natural behavior is incredibly difficult. The chamber must be shielded from light and heat immediately. Now, the tubes are connected to the natural nest chamber in the mound. This is a tense moment. If the queen is stressed, workers and soldiers will kill her instantly. Now comes the waiting. Will the queen and workers resume normal routines? Will they eat, lay eggs, and care for larvae as before? Even with Joanna Darlington and Reinhard Little's experience, they still need a bit of luck. The queen and workers seem undisturbed. The workers continue tending to her, and the queen keeps laying eggs, hundreds per hour. All eggs are identical. Whether they become soldiers or workers depends on food they're given. Fragile in the wild, yet resilient elsewhere. The termite mound shows they're worth our attention. Wherever you live, check your home regularly and listen carefully. Something might save you from a big shock. And so, we've explored the mysterious world of termite superorganisms, where underground secrets have been unveiled. We hope tonight's story has brought you moments of relaxation, a touch of mystery, and a ticket to serene dreams. Thank you for joining our channel. And don't forget to like, subscribe, and hit the bell to stay updated on our next mysterious tales. Wishing you a restful, deep sleep filled with beautiful dreams. See you in the next storytelling night.